Hello everyone, welcome again. This is lecture number 8 in this lecture series of transportation engineering. In this lecture, we are going to solve some problems based on what we have studied till now. Till now, we have covered horizontal alignment in geometrical design portion. In this lecture, I have included some of the problems from vertical design. Vertical design includes summit curves and valley curves. Summit curves and valley curves we are going to study in coming lectures. But if you feel you are not able to understand the problems what we are discussing, you can skip that problem. And after studying lecture number 9 and lecture number 10, you can come back here again and solve these problems. So if you feel that you are not able to understand, just skip the problem. Let us start one by one. Before starting, I want you to bring your paper and pen and a calculator so that we can solve these problems along. This is question number 1. This question says the camber provided on a sloping road is 1 is in 66. So the camber provided here is 1 in 66. Okay. So what is camber? We know that it is the cross slope which is available on the road in order to drain off water. So the camber value is 1 in 66. Now what the question is asking, which one of the following is the ruling gradient? So from the concept of camber, we know that there is a relation between gradient and camber. There is a relation between gradient and camber. Gradient is twice of camber. So if I write gradient as twice of camber, I can write it as 2 multiplied by 1 by 66. So solve this, I get 1 by 33. So it is a very easy question. 1 by 33. Here the question can be, for a CC road in heavy rainfall, what ruling gradient is provided? So you know that for CC road in heavy rainfall, the camber value is 2%. So if camber value is 2%, the gradient should be twice of the camber, and camber which is 2% is multiplied by 2 comes out to be 4%. So the gradient for a CC road in heavy rainfall is 4%. So this is how we can calculate the value of gradient from camber. Let us move on to the next question. Next question says, if the difference in elevation means level, between the edge of the pavement of width 9 meter and its crown is 7.5 centimeter, what is the camber of the pavement? Okay, let us draw the camber profile. We are drawing here straight line camber. Okay, this is the camber profile. The question says that the width of the pavement, complete width is 9.0 meter. Okay, what does it says? It says the level difference or difference in elevation of the edge, this is the edge, and the crown, this is your crown, is 7.5 centimeter. So they want to know the value of camber. They want to know the value of the slope theta. We can calculate camber by dividing this 7.5. This is a triangle. This base of this right angle triangle is 4.5 meter. This is the height, that is 7.5 centimeter. So we can write this tan theta as 7.5 by 4.5. The centimeter is 4.5 meter. Let us convert it it into centimeter, multiplying by 100, 75 centimeter. The ratio is 75 divided by 4500. Let us calculate. It comes out to be 1 by 60. So it is a very simple question. This can come in 1 mark in your GATE examination. It can come for 1 mark in your GATE examination. There can be question with the variation, the same which we discussed earlier, any road condition or road type, and the rainfall condition is given. From there, you will calculate the camber value. They will give you the width of the road, and they may ask the elevation difference between the edge and the crown. So this is how you can calculate each and every value. Again, the next question is from camber only. Okay, so for a road with camber of 3%, camber value is 3%, and the design speed as 80 kilometers per hour, the minimum radius of the curve being which no super elevation is needed. They're asking about the radius for which super elevation is not required. Camber itself work enough for the curve. So let us calculate. We know that radius is equals to p square by 127 e plus f. They are not providing super elevation. Instead of super elevation, we have this camber value, because while we provide a super elevation, we remove the camber and or we exceed the camber, we increase the camber to a limit up to super elevation. So we can write super elevation here. Super elevation can be replaced by the camber value. So this equation can be written as v square by 127, super elevation is 0.03, plus the value of lateral friction coefficient. The value is 0.15. This you need to remember. It is not given in the question, and in most of the question they expect you to remember this value. The answer is coming out to be 279.96, 5 meters. So if we round off, this D option is the nearest one. I think this question is clear. This is not a very difficult question. You can easily put the values in the formula and get the answer. In next question, the examiner asks the design speed of highway is 80 kilometers per hour. Okay. Assume other data as per IISc and calculate the value of approximate adopted lag distance. Now remember, where did we studied about lag distance? Correct. We studied this in stopping side distance. When we write the formula of stopping side distance, SSD, this formula comes out to be Vt plus V square by 2gf. Here this value is your leg distance and this value is your braking distance. Okay, leg distance and braking distance. So the examiner wants us to calculate the value of leg distance. He has provided us the value of V and he wants us to assume the value of T. We know that educated guess for T from IRC is 2.5. We need not to guess, we have to remember this value. Very important value, 2.5 for SSD and 2 seconds for OSD. So let us write the equation as 0.278 in order to convert this kilometer per hour into seconds. T80. Now calculate the value. The value is coming out to be 55.6 meters. There are some round off in this first conversion factor. So the nearest value which we are having here is the option A. If the question require us to find out the total SSD, that too we can calculate, because the F value is known. For longitudinal friction, 80 kilometers per hour and 100 kilometers per hour, the value of longitudinal friction is 0.35. We can calculate the braking distance also. Next question says the design speed on a road is 60 kilometers per hour. The design speed is 60 kilometers per hour. Okay. Assuming the driver's reaction time as 2.5 seconds. We know that for SSD, the driver's reaction time is 2.5 seconds and coefficient of friction as 0.35. Okay. The required stopping side distance for two-way traffic on a single lane road is, they're asking about two-way traffic. Means this is a road, vehicle in a single lane are moving in this direction, and on the same lane vehicle are coming in this direction. So what we need the side distance for this vehicle and for this vehicle, so that they can stop before colliding. So what we need two times of the value of side distance. Okay, let us calculate SSD for one vehicle, then we will double it. We know that the formula is for kilometers per hour. We can directly write the formula as this is the formula. We can put in the values as most of the values are given. The G value we need to assume. Whenever you are using G value, you need to be little bit cautious, because if we use value of G as 10, there may be some variation in quotients. So better use 9.81 instead of 10, so that our answer is exactly equal to the required answer. Because in GATE examination we have filling type question also, in which options are not provided. So we need the exact solution. So here the answer is coming out to be 82.21 meters. The answer is here, but this is for one vehicle. Don't get confused. If you calculate, after the calculation our mind is convinced that this is the answer, and if we see this option in the options, this value in the options, we directly put this value as the correct value. But no, we need to put the value of SSD as twice of this value. So let us multiply this by 2 and write the nearest value of our answer as 164.2. Why? Because for two-way traffic on a single lane, we require SSD equals to twice of SSD. Where SSD equals to twice of SSD. I expect you will not make such kind of mistakes in your examination. So remember this thing. Another question. This question says a vehicle is moving at a speed of 60 kilometers per hour. Vehicle is moving with a speed of 60 kilometers per hour on an ascending gradient. What is ascending gradient? Whenever you are moving up the slope, this is a slope, this can be descending, this can be ascending. But whenever you are moving up the slope, this is a ascending gradient, means your vehicle is moving in this direction. Okay, what else of a highway has to come to stop position to avoid collision with a stationary object? Okay, the question is talking about SSD because he wants the vehicle to stop. Fine. The ratio of lag to brake distance. What is lag distance? The time or the distance covered while making the decision. And the brake distance, it is the distance covered after application of brake before we comes to a stationary. So lag distance to brake distance, the ratio is 6:5. Okay. Considering the total reaction time of the driver as 2.5. Okay, for SSD we know that the value is 2.5 and the coefficient of longitudinal friction for 60 kilometers per hour is 0.36. He wants us to find out the ascending gradient. Fine. We know that SSD value equals to 0.278 Vt plus 0.78 V capital V square by 2 V F plus minus is when it is a descending gradient. So let us remove the minus. F plus n%. N% means n divided by 100. This value is n divided by 100. So this is the total SSD, where this is your lag distance and this is your braking distance. Okay. Now we know that what question says lag distance by braking distance is equals to 6/5. From this equation, we can write this as 0.278 Pt divided by 0.278 V square whole divided by 2G F plus n%. Fine. Let us simplify this value. We can remove this by the square and we can simplify it as 2G T F plus n percentile divided by 0.278 times P. This is equals to 6/5. Let us put the values and again simplify it. 2 multiplied by 9.81 multiplied by the time t is 2.5 seconds. F value is 0.36 plus n percentile or percent divided by 0.278 times 60 equals to 6/5. Let us simplify this. Uh, this is coming out to be 0.36 plus n% is equals to 0.408. Okay, let us write n% is equals to 0.408 minus 0.36. Okay, I know this is behind me, so let us write it here. The n% is 0.408 minus 0.36. This is coming out to be 0.048. So to convert it into n%, the value is multiplied by 100. So the value is 48%. Here the B option is the one which is matching with our solution. So this is how you can calculate the value of n. If it is descending gradient, you should write minus. You should write minus here in place of plus, and you can solve the solution in the similar way. So ascending gradient and descending gradient can be calculated by this way. Okay, let us move on to the next question. If you have any doubt here, you can ask in the chat box. At a horizontal curve, the portion of a four lane undivided carriageway. So let us say 4-lane undivided carriageway. Just for the discussion, let us see what is the width of this carriageway. For a single lane, it is 3.75. For undivided carriageway 2 lanes, it is 7. For more lanes, for any undivided carriageway, add 3.5 for each lane. So for 2 additional lanes, we'll add twice of 3.5, that is 7 to 7. So total width is 14. We may use it in the question, may not, but just for the discussion, the 4-lane undivided carriageway is of 14 meter. If it is divided carriageway, let us add the median on this length. So a transition curve is to be introduced to attain required super elevation. Okay, so a transition curve is provided so that super elevation can be introduced. The design speed is 60 kilometers per hour. Again, from last many questions, the design speed is 16 kilometers per hour. I don't know why it is so, but it is. Radius of the curve is 245 meters. Okay, radius of the curve for which this transition curve is made is 245 meters. Assume the length of wheelbase of a longest vehicle is 6 meters. Fine. Let us write the values what we have one by one. We have design speed V as 60 kilometers per hour. Then we have the radius value as 245 meters. Okay. Then we have length of wheelbase L as 6 meters. Super elevation rate, this is E value as 5%. Then we have rate of introduction of the super elevation, that is N value as 150. Okay. They want us to calculate the length of transition curve which need to be provided, and they are saying if the pavement is rotated about its inner edge. Okay, we know that this value will be used in the formula which is based on the rate of change of super elevation. So let us calculate the length of transition curve by first method, rate of change of super elevation. Okay, so the formula is length of transition curve is equals to E times N, width of road plus width of extra widening or extra width. This W which we have calculated here, now we can use it. The W width of road is 14 meter. Fine. This value is required, that is WE. So we will write WE as the extra widening is provided for mechanical reason and psychological reason. We have already discussed this concept in our lectures. So we know that mechanical extra widening is N times L square by R, plus the psychological extra widening is V divided by 9.5 under root R. This we have already discussed in our conceptual lectures. Now let us put the values and calculate the answer. Here it is clearly written that it is 4 lane, so we will put the value of N as 4, length of wheelbase as 6, radius as 245. Then the psychological extra widening, we need velocity in kilometers per hour, 9.5 divided by R, that is 245. Let us calculate this value. The mechanical extra widening is coming as 0.294 plus psychological extra widening, which is 0.403. Let us add these up. Value is 0.67 or 6975, 698 we can write as meters. So let us calculate the rate of change of super elevation. Length of transition curve equals to E value as 5%, 5 by 100, multiply by N as 150, multiply by width of road as 14 meter and the extra widening 0.698 meter. Add up these values and calculate the value of transition curve, length of transition curve. The value is coming out to be 110.23 meters. We have two other formulas to calculate length of transition curve, but if we see at the options, the value which is coming out to be is the highest one, and we know that we take the highest value out of all these three formulas. Let us write the three formulas. This is based on your rate of change of centrifugal acceleration. This is length of transition curve is equals to E cube by CR, where C is equals to 80 by 75 plus VKmph. Okay, this is one formula. Another formula, length of curve, the length of transition curve is equals to 2.7 times V square by R for plain terrain, and is equals to V square by R, sorry, capital V, this capital V in kmph by R for mountainous or steep terrain. If we calculate the speeds, or sorry, the length of transition curve by the other two formulas, there is possibility that they will not reduce, or sorry, not exceed the value of length of curve obtained here, because if they exceed, there is no option which we can take. So the best option from the given options is the fourth one, that is 110.23. We can calculate for our practice the length of transition curve from these values or these formulas. in comment section or chat box, please let me know if these values are coming high or more or less as compared to the first value. Let us move on to the next question. Next question is, next question wants us to calculate the ruling radius. What is ruling radius? The minimum radius which can be provided on the road for safe transition. The horizontal curve on an NH for a design speed of 100 km per hour, where the E value is 0.07 and F value is 0.13. I want you to solve this question and mark the correct option out of these. You know that the ruling radius is calculated using the same formula, V square by 127 E plus F. Now you can put the values in this formula and calculate the value of R. Okay, so here is the question about extra widening required for 2-lane national highway at horizontal curve of 300 meter, considering a wheelbase of 8 meter and a design speed of 100 km per hour. We have already calculated the extra widening here. You know the formula. Let us write the formula again. Extra widening equals to P in kilometer per hour This is the formula. Just put the values and find the answer. You can discuss the solution in your chat box, in your comment section, or on the Telegram group. The link is provided in the description box. This is a very important question. This question is not numerical, it is a conceptual kind of question. But while you read this question, you will understand the importance of super elevation. What this question says, if super elevation is not provided on a horizontal curve of a highway, then on which portion of road are potholes likely to develop? What are potholes? Potholes are the holes which are formed on the road because of removal of material, the pavement material. Whenever there is a horizontal curve, there is a possibility that vehicle is pushed outside. As the radius is decreased, this push increases, and this push is known as centrifugal force. When there is no circular curve, the pressure bulb below these tires is of same pressure. Both the tires are applying same pressure on the road. But as radius is introduced, this pressure bulb increases on the outer side. On the outer side, this pressure bulb increases, and here this pressure bulb decreases. And at maximum value of super elevation or maximum value of centrifugal force, this value increases to the maximum and this value decreases to 0. And after this, we assume that the overturning will take place, because if there is no pressure, this means there is no pressure, there is no force applied by this tire on the road, means the tire is not touching. This means tire can move up and this body can overturn. So you know that if super elevation is not provided, the outer edge of the road, this is inner, this is outer, because whenever we are moving on a circle, the centrifugal force is applied outside. So this is the side which is nearest to the direction of centrifugal force. So this is known as outer edge. So outer edge gets more pressurized, and because of this pressure, it gets eroded. So answer is the outer edge of the road is likely to develop potholes. I think you are understood what the concept behind this problem is. Okay, let us discuss the next question, the absolute minimum radius. The question which we discussed previously, the same question with less values. Here, the value of super elevation or longitude lateral frictional coefficient is not provided. So you have to assume the values of E and F, and then you can calculate the value of absolute minimum radius, that is ruling radius. So we can write the formula as 127 v square by 127 E plus F. We can assume the E value for maximum for a plain terrain, and F value we know that it is 1.5 for lateral friction coefficient. We can put these values and check whether any option matches with our solution. Let us calculate this. The answer is coming out to be 433.07 meters. Yes, there may be variation because this value is not exactly 127. This value comes from 3.6 multiplied by 3.6 multiplied by 9.81. So if we say use, we can get the answer as close as 440. So this is a very simple question. Just the assumptions are required, which are already known. Okay. Next question says the design speed of a highway is 80 kilometers per hour. Okay. The radius of circular curve is 150 meter. Fine. In a plain topography. Fine. Which one of the following is minimum length of transition curve? In this question, this previous question, we saw the transition curve can be calculated by a rate of change of super elevation, the change of centrifugal acceleration, and this IRC formula. For the rate of change of super elevation, we need quite a few values like super elevation, E, extra winding will require length of wheelbase, number of lane, but these values are not provided in this question. So as per assumption, they want us to calculate the transition curve by second and third formula. Second formula is by rate of change of centrifugal acceleration, where transition curve length can be calculated as B cube by CR. Here the C value is 80 divided by 75 plus BKMPH. Let us calculate the value of C. Generally, it comes out in between 0.5 to 0.6, as we have already studied. But for this question, as we have the velocity, we can calculate it. The values, sorry, value is 0.516. Okay. So it is between 0.5 and 0.6. You can ultimately take 0.5 and you'll get as these values are not nearby, you can get approximate answer just by assumption. So what is V? V is 80 kilometers per hour, but this value is in meter per second, what we need to put here. So let us multiply it with 0.278, and then C value is 0.516. What is R? R is the radius, which is 150. Now let us calculate. The answer is coming out to be 142.08 meters. As this is not exact, this is rounded off the last value. You can say that it is nearer to this value, but we need to find out from the IRC formula also. For plane topography, the formula is given as 2.7 times VKMPH square by R. Let us see what value of length of curve we get from this formula. Okay, this formula is giving us the value 115.2 meters. We need to choose the value which is highest in order to accommodate all the conditions. So this value will satisfy the IRC condition also. So we'll take this value as our answer. We have 140 as the nearest value of our solution. Hope this question is clear to you. This next question says a road is having a horizontal curve of radius 400 meters. So radius is given as 400 meters. Okay, on which a super elevation of 0.07 is provided. E value, it is maximum value for plain terrain provided. The coefficient of lateral friction mobilized on the curve when a vehicle is traveling at a velocity of value is 100 kmph. What is asked? They're asking us the value of F. In the past few questions, we have already discussed many times this formula. We can calculate the value of F from these formulas. So I hope you can solve this question easily. If not, you can, after solving, you can write the solution in the chat box or in the comment section. If there is any error, I'll correct you. And ascending gradient. Ascending means gradient which is moving up. Meets and descending gradient. Okay, it meets with a gradient which is coming down. The ascending gradient n value is n1 is 1 by 100, n2 is 1 by 50. This is minus plus, ascending and descending. The length of summit curve required to provide a overtaking side distance of 500 meter will be. Okay, so we are providing a summit curve here, and the design of or the length of summit curve is based on your side distances, either your SSD, OSD or ISD. The length of curve, when length of curve is assumed to be more than your side distance, for OSD it is n s square by 9.6. Your S is your OSD, that is 500 meters, and your N is plus N1 minus of N1. Let us write 100 minus 150. This is 3 by 100. Okay, let us put the values in. 3 by 100 multiply by S square, that is 500 multiply by 500, and whole divided by 9.6. Let us calculate the value. The value is coming out to be 781.25 meters. Assumption was length of curve is more than your side distance. Your side distance is 500 meter. The length of curve is 781 meter. So assumption is correct. And we have an option which is nearest to our solution also. This is the solution of this problem. If SSD is given, we can use the formula of SSD as ns square by 4.4. If there is any question in which the length of curve is less than SSD or OSD, you can use the formulas as length of curve is 2s minus n by 4.4, and for OSD length of curve equals to 2s minus n by 9.6. So this is the formula which you can use for length of curve less than your side distance. Let us move on to the next question. The question says, what is the value of off-taking while negotiating a curve of radius 40 meter with a wheelbase of 7 meter? Off-taking means whenever we are moving on road, because of the rigidity of wheelbase, on a curve, our wheelbase turn to move off the road. That's why we provide an extra widening. So in this question, the examiner is asking you the mechanical extra widening. Why mechanical? Because only the radius and the wheelbase length is given. If the velocity is also given, then we would have calculated the psychological extra widening also. So let us calculate mechanical extra widening as or n L square by 2r. The n value is not available. So let us take it as a single lane road. If the width of road given, then too we can assume the value of n, but as nothing is given, we can assume the width of or the lane number of lanes as 1 only. What is L? L is the length of wheelbase. This is given as 7, so we can write as 7 square. What is R? R is the radius. It is 40. Let us calculate this value. The value is coming out to be 0.6125 meters, and we have this value 0.61 in the option also. If in this question the extra winding specifically asked and the question is provided with the velocity or design speed or the road type, if it is written here for a plain terrain, we can assume the road design speed of road as 100 kilometers per hour, and then we can calculate the psychological extra winding also. But here nothing is given, so mechanical extra winding is taken as off-taking. This is a very important question. This talks about the compensating gradient. The compensated gradient. The compensated gradient provided at the curve of radius 60 meters with a ruling gradient of 6%. Now look at this question. If this value given for ruling gradient is 4, if it is less than 4%, then no extra widening, no grade compensation is provided. But as this value is more than 4%, we will provide grade compensation. And we have two formulas for grade compensation. First formula is 30 plus R by R percent, and second formula is 75 by R percent. Out of these two, we take minimum value. Let us calculate from the first value. It is 30 plus 60 by 60. The value is coming out to be 1.5%. And from the second value, it is 75 by 60. The value is coming out to be 1.25%. So out of these two, the minimum is 1.25. So we can take this value as grade compensation. But what the question is asking, it is asking compensated grade. Grade compensation is the value which is reduced from the value of grade provided, and the compensated grade is the value of grade after the grade compensation is applied. So the compensated grade will be equals to 6% minus 1.25%. This is 4.75%. This is it. This is your compensated grade. I hope this question is clear. Many a times you will encounter with a kind of problem which is given here, and many times you will have a value of grade as 4%. So you need not to apply the value of grade compensation or the calculation of grade compensation for a grade provided less than 4%. This question is from vertical curve. As it is written here, a crust vertical curve joins two gradients. One is 3% and minus 2%. Means there is a curve joining N1 gradient or ascending gradient of 3% and a descending gradient of N2 as minus 2%. Okay, so this is used, this summit curve is used here. For a design speed of 80 kilometers per hour, we have the design speed value as 80 kilometers per hour. The corresponding stopping side distance of 120 meters. You have the side distance value as 120 meters. The height of driver's eye is taken as 1.2 meter. Driver's eye H1 1.2 meters, and the height of object H2 is taken as 0.15 meter respectively. So they are asking the curve length. They are asking the length of curve, length of summit curve. The length of summit curve is based on the height of driver's eye and the, or it is based on the side distance only. But here it is written that the length of curve is less than ST. Means we need not to assume here. It is specifically given that length of curve is less than your side distance, and this side distance is your SSD. So the formula applicable here is, we had already seen the formulas. These were the formulas when length of curve was less than your SSD. The formula for stopping side distance was, let us write here, length of curve is equals to 2s minus n by 0.4. Let us calculate the value of n. N is plus n1 minus n. Here it is 3% minus 2. That is 5%. Okay. The S value is given as 120. So we can write it as S is 120 minus N is your 5%, or you can write 5 divided by N is your 5%. 100 divided by 4.4. Let us calculate what we have here. This value is comparatively very less. If we see, so the value is coming out to be nearest 240 meters. I'm finding this solution a bit confusing, but I think okay, I have made an error. Please correct this. It is not n by 44, it is 44 by n. I am really very sorry. I have made an error. This is 9.6 by n. So you can correct it here. We corrected. There's nothing much damage is done because we have not passed this question. Or let me correct this for you. Sorry for the error. This is 4.4 divided by n. So n value is 5%. Now we will get 2 multiplied by 240 minus 4.4 divided by 5 multiplied by 100. So this value is coming out to be, this is correct now. I hope you can follow what I have done here. This is not 240, this is 120. The answer is coming out to be 152 meters. Okay, now things are good. I'm sorry, what was the formula? Let me write it again. Length of curve, this is for SSD, and ISD. For OSD, length of curve is twice of your S value minus 9.6 by n. This was the formula. You can go back and correct the formula which I have written in a few questions back. Okay, so this is the question which you are going to do. I think this is the last question, and this question is on valley curve. So what is a valley curve? When a descending gradient meets an ascending gradient. So the curve which is formed, the valley curve, and this is designed on two conditions. One, your comfort condition for passengers. Second, night time SSD. So these are the two conditions which can be used. So what the question says for a design speed of 80 kilometers per hour, the deviation angle of the curve is, or the valley curve is 1 by 20. What is deviation angle? This is deviation angle. This is actually the n value. This is 1 by 20. Then the length of curve for comfort consideration is nearly. Okay, so they are asking only about the comfort condition. What the comfort condition is? Comfort condition is, let us write length of curve when it is 2 times root of nvq by c. The c value itself is between 5 to 6, 0.5 to 0.6. So we can write the values inside. N is 1 by 20, is 1 by 20, is 0 point, multiply 0.5, and v cube is in terms of meter per second. So let us change this in meter per second. So let us correct it. 0.278 multiplied by 80 times cube divided by 0.5 divided by 20. Nothing much changed. Under root of this answer, multiply by 2. So this value is coming out to be 66.33 meters. The nearest value is 61. This means the value of the C is a bit more. That then only this will reduce. But as it is assumed, it can be assumed between 0.5 to 0.6. If it is based on your headlight side distance, this value can be written as, or the length of curve can be written as n s square, your s is side distance, divided by 1.5 plus 0.035 times s. So this is the formula when length of curve is more than your side distance or your s value. If length of curve, okay, let me shift a bit. Length of curve is less than your side distance, then we can write this formula as 2 times s minus reverse whatever we have, 1.5 plus 0.035 times s divided by your n. So this is, I hope this is visible behind me. Okay, so this is the formula which we can use when length of curve is less than your side distance. Okay, so this is the end. I hope you learned or revised most of your concepts. If you need more videos of this kind, you can ask us in comment box, or you can write us on Telegram group. If you have any doubt in any of the question or any of the concept, you can directly ask us. Thank you so much.